Welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at differentiation and we are using method 2 that we are calling the first principles. So example 2 says differentiate the following from first principles. So the solution is for part A, where we are given a function y equals to 6x plus 1. We need to differentiate this function from first principles. Number one thing that you must know is the formula, which says that if we are differentiating a function dx, if we are differentiating a function dy dx, the formula says it is limit as h tends to 0 for the function f of x plus h plus, it is not plus here, it is minus, you must always put the minus f of x over h. This is the formula. Here is minus, it is not plus. The moment you make it plus, you get the wrong answer. So after stating the formula, then you come and say, this is the function y in terms of x. So you say let the function y be the same as f of x, which is true. Y is a function in terms of x. Therefore, f of x now, which is the same as y, equals to 6x plus 1. So we have one of the terms that we need. This is the function f of x. What is the next thing that we need? We need the function f of x plus h. So for f of x plus h equals to, you simply use the function f of x to give you the function f of x plus h. What do you do? Where you find x in the function f of x, you use x plus h instead of x. You substitute for x as x plus h. That means we shall have 6 into, instead of writing this x here, we shall write x plus h. X plus h. And then we proceed there plus 1. Because we simply substitute for where x is. And then from here, we open the brackets, giving us here 6x plus 6h plus 1. This is now our function f of x plus h. After getting the function f of x plus h, then simply we need to substitute in the formula because we have the terms that we need. So we come and say, therefore, dy dx, our markers. Then you say dy dx equals to limit as h tends to 0 for the functions. What is f of x plus h? F of x plus h is here, which is 6x plus 6h plus 1 minus, the formula says minus, we are going to subtract away f of x. F of x here has two terms, that is 6x plus 1. The moment you are taking away two or more terms, you put them in the bracket. So we say minus, open the bracket, 6x plus 1, close the bracket, and you close the bigger bracket of the formula over h. Now let us simplify the numerator, keeping everything the same. So limit as h tends to 0 for 6x plus h, 6x plus 6h plus 1 minus, if you open the bracket there, we shall have minus 6x minus 1 over h. Then we simplify 6x minus 6x, they will cancel. Positive 1 and negative 1 will cancel. That gives us limit as h tends to 0 for the function. We shall be left with 6h because these are cancelled. We shall be left with 6h out of h. Then we simplify. This gives us limit as h tends to 0 for the function of 6. h and h are going to divide and they give us 1. Now, if you look at this term 6 here, it doesn't have a term h, okay? It is independent of h. That means it doesn't matter what the value of h is. 6 will not be affected by the value of h. Therefore, you say dy x equals to 6. So this is the answer when we are differentiating the function y equals to 6x plus 1 from first principles. You can check if your answer is correct before you leave. Y is given as 6x plus 1. Use the other method of powers and coefficients. So here we shall say dy dx equals to, this one has a power of 1. So we shall say 6 times 1. X power 1 minus 1 plus, if we differentiate 1, we get 0. This gives us here 6 x power 0, which is the same as 6. So we are certain that our answer is correct. So this is the solution to part A.